Hello guys, just wanted to record a short video on this new RAC method, paper of which has been just released, 1st February 2024, as you can see it here. RAC stands for Retrieval Augmented Generation, and here they're proposing something novel that outperforms all the existing methods known in the industry, and we're gonna break it down real quick. This paper is full of interesting details. I made an entire tweet thread about it, explaining their methodology step by step, bringing some relevant pictures and excerpts from the paper, so definitely have a look. But I also want to explain it to you in the video, so let's get into it. The framework consists of 3 stages. The first one is to extract data from various documents. Could be PDF documents like this paper, or websites converted to PDFs, or virtually anything, I would imagine. So the goal is to come up with a structured database of such, okay? So for that reason, they convert those documents to Markdown files, but they also augment it with some additional metadata. They basically represent all those documents in Markdown, but with like hierarchical chapters, and they also add the chapter title to it. Those are not fixed chunks of data that you see in the documents. They overlap. There's some overlapping thing, and they apply pretty much sophisticated mechanism to make it possible. Which brings us to the second stage, which is hierarchical contextual Agmentor. And that is basically extracting embeddings from various types of data, okay? Identified early in the previous step in those documents. For the textual data, and for that we've got like, it covers like title and content itself. So it's just basically taking this data through LLM. Virtually any LLM has this embedding functionality or endpoint, think of it either way, which allows you to extract numerical representation of the meaning of the text you're sending to it, okay? So that's gonna cover that piece, but they've also got like tables. Sometimes you can see like various tables in the documents or even images. So they've got it covered too. For the tables, what they do is that strip out all of the like cell values from the table. They're leaving just these like column names and row names, basically the header. The most important piece that will help direct the retrieval to this particular piece of content if it thinks it's relevant, okay? So they leave whatever is in red on this picture and take embeddings from it, okay? This is, and they store it in a separate space, separate database, okay? And for the pictures, what they do is that they actually implement this visual language model, the point of which is to extract the meaning from the picture, right? We know that this latest LLM model, like GPT or Gemini, they can do that, right? You can send the picture and it will tell you what it sees there, okay? They apply the similar technique to do just that. And this is what they basically doing and storing in as a separate data set for the later retrieval. And the final stage is a multi-route retriever. That is what's gonna compose a final context for your QA task, essentially, okay? And they combine 3 methods here. First one being vector similarity matching. That is, you know, typical vector similarity search as we know it. Any vector database can do it for you these days. It's just to find the closest match in the embedding space based on your input query, okay? That is as simple as it is. Second one is Elasticsearch. That is to augment that method with a keyword-based search, because sometimes a requester, a user, like they don't express their thoughts using like natural language, or like fully trying to explain themselves. Let's just put a couple of keywords. So sometimes you need this keyword matching mechanism, like functioning under the hood, to point to the right documents in the first place, okay? But they also, what they also do, like they also apply this third method, which is like also keyword based, but they use this special pre-trained model, entity detection model, to identify these critical named entities, okay? And it just like improves the keyword match overall. They also have this scoring function to calculate the score of the results from those methods. That is to be able to prioritize the matches found across all of the chunks from those documents and to be able to feed them in certain order to the requester for the final QA task K. They have a couple of parameters that will allow you to control the effectiveness of either of the method. That is for you to balance out those methods in a way, right? And adjust to a certain data set that you're necessarily working with. To measure the effectiveness of the proposed method, they introduce this new metric for RAG. And as it claimed, it utilizes a nonlinear logarithmic ranking function, okay? And that addresses shortcomings of linear scoring methods such as RAGs. They're also coming up with this mass QA dataset to be able to compare the various RAG mechanisms for the matter, okay? This is a final benchmark table with their method being in the first line and others just with relative results. As you can see, they outperform alternative methods such as LlamaIndex, ChatPDF, Chat4Doc by a big margin, in fact, on various data sets. Finally, they provide with the implementation of their thing. It's stored in the HiQA repository. It relies on OpenAI, as you can see in the how to use section. They have these supportive services to for Markdown conversion, for extracting semantic meaning off of the pictures, okay, various things here. They have data sets here as well, and the actual implementation in the knowledge client pie. It is an interesting RAG mechanism indeed, especially given how much it improves the results over the alternative methods on their benchmark. It is not complex to implement to me. I think it's pretty much straightforward, especially given the fact that they're already providing with implementation in their repository you can reuse for your projects. I hope it catches your attention, your interest a little bit so that you want to play around with their code base and test it on different data sets. If you want to implement it for your practical use case, that is totally fine too. If you want to discuss, you want to bring it to the cloud, come up with a cloud solution architecture design of sorts, just let me know. I'm a cloud architect, would be happy to assist you with this case for sure, especially when it comes to AWS and GCP clouds. And stay tuned for more interesting content.